Today we'll talk about how to build applications with large language model. This is aimed for software engineers who are interested in gaining practical experience with AI and large language models. So today we'll briefly talk about how LLM is used in Apple Intelligence, and then introduction to how it's being used in technical world. And then we'll have a brief introduction to RAG and factor database. And in the end, last not least, we'll talk about the LAN chain and the LAN chain agent. Apple Intelligence is kind of like a Jarvis in LLM, right? It's like the artificial intelligence assistant for you. So that's what they're trying to achieve. Basically, when you ask it something, it trying to answer you, and actually to be more intelligent, it actually trigger apps for you. So app intent is something existing long before Apple Intelligence happens. It's a contract between the app developer, and iOS or macOS, right? Let's say when we ask Siri something, let's say book me a flight, it actually will invoke the apps that is for flight booking, right? If you ask like check my calendar or check my notes or write something, add something to my note, it automatically, right, talk to your note app, right? And the way it communicates is through Apple app intents. Right now I would only talk briefly about the concept, and as we go through the rest of the topics, it will make more sense. And as Siri already has this contract with the app developer, and it supports different apps, right? And the app can interact with Siri, and the model, the LLM, is actually behind it to support all this, make it smart. And there's a lot of many teams working on Apple Intelligence, right? So I will speak from my personal experience because per the project I'm involved with about synthetic data generation. LLM is very good at the synthesized data. It's basically fake data, right? Because Apple protects users' privacy. You cannot use like production data or users' data, right? And LLM is actually very good at making up like names, address, phone number, credit card number, right? This can be fake. And this data, we need a large amount of data. The scale has to scale in order to train model. So we need a large number of data, and by using LLM, right, instead of handcraft data, we can generate millions, billions, right, trillions of data to train the model, and without use real user, right? So how are LLM being used? From this picture, if you look from top to bottom, the more it towards top is easier and cheaper. The more towards the bottom is more difficult and expensive. We'll go through one by one and you'll understand why. The first top one is the prompt engineering. Almost everyone can be a prompt engineer because nowadays when you ask ChatGPT something, you are basically making prompts, right? But are you very good at it? So prompt engineering is about asking the right question, right? Because LLM can only give you the right answer if you ask the right question. As basically, if you recall, this is from iRobot, the movie, and if you have a zero example in your prompt, it's called zero-shot learning. And if you have one example included in your prompt, it's called one-shot learning. If you have multiple examples, it's called few-shot learning. So prompt engineering actually doesn't, in fact, change the model, right? It's basically try to enhance the quality of your prompt so that you can get more accurate answer. The second thing is RAG, retrieval augmented generation. So this is a concept that because your model only uses the trained data, right? And after it's trained, it doesn't know about the facts that happen after the training, right? So also they don't have access to non-public data. So if you have some like internal data, you want to enhance the prompts, you can basically store those documents into your factor database. We'll talk about the factor database later. right? It basically is a kind of database. And the purpose of this is when user asks a question, you can get related documents to enhance the prompts. This is a technique to augment the prompt with external data in form of documents. And as you can see, both of these two technique, prompt engineering and RAG, it doesn't actually change the model. And that's why they are cheap and easy, especially if you don't have access to modify or to actually alter the model, right? If you are using a third-party model, this basically is the most practical way for most company who doesn't have enough money to burn to train model to have their own models. They basically just pay as they go to use some other companies' model. So this is the basically and also more like a software engineer approach, which you don't have to have a huge number, a lot of experience with the machine learning, and you can be good at it. After the documents are already stored in the factor store, then how it's being used is that when user asks a question, the system basically search through the factor store to find a similar document. So basically it has some calculation and mechanism for similarity, which is actually more complicated than it looks. And also related area how do you make sure your factor database is doing what it's supposed to do, able to find the most relevant documents, right? You cannot just grab every document because it has a context window with limited token. You can just envision a token is just one word, right? So when you ask ChatGPT, there's a limitation how many words you can use when you generate the prompts, right? So same thing applies when we use RAG, because the result of the RAG retrieval is being used to added into the query prompts, and there's a limitation, right? So basically, usually we find the top K most related documents. And you basically there's a lot of work how do you evaluate and test to make sure your RAG is working as expected. So there's a framework like RAGs and stuff, to do the calculation, to test it. So the AI then the AI use both your original question, right, and the original prompts, and also the retrieve the documents and information to create an accurate answer. Speaking of vector database, you as a software engineer, you are probably very familiar with it already. With database already, right? We have you're probably more familiar with the key value store like Redis, document store like MongoDB, graph database of course, and of course a relational database. So imagine vector database is tuned, right, more towards for vector, and we'll talk about what is vector later. Because we already have different kinds of database serving different purpose, right? Like time series database, like InfluxDB is for time series data, right? Which is only increasing, right? And then you have a relational database, you have NoSQL, and the fact that database is more towards finding similar. It's like you are doing a Google search, given a few keywords, and it finds related link or documents for you, right? Very similar. Imagine basically it's like a search. And as we know, right, why it's called vector? Now we are trying to demystify it, and because the machine can only working with numbers, right? And here basically the numbers are basically the embeddings. Like here, those words are converted into numbers, which we call the embeddings, because the machine can only work with numbers. Not just the language, also like audio, video, like a different kind of like a multimodal input can also it's also like translated into embedding. So that's how it works. Here, this picture show a 3D, like more like three-dimensional, but it's actually you can it is actually more than 3 dimensions, right? We are as a human being, we are more familiar with 2D or 3D. I mean, usually when it's, usually our human brain cannot handle 4D, right? I mean, not even 5D, 5 dimension. But actually, in a vector is more like a one kind of like this form, right? And I'm trying to say is actually in real calculation is actually more than 6 dimension, like probably n dimension. And here, probably make it looks better. Like you can see, like king is closer to man, and the queen is closer to woman. This is just the illustration, like how give you a rough idea. So basically, there's a different kind of similarity score or standards, like cosine similarity. So this is a specific detailed process of building a RAG, which we already explained the rough idea. So the first step is the indexing process, right? You load the documents. The documents can be huge, big, right? I mean, usually you do not expect to put a single huge document into the database. So you split it, right? Text splitting. You split it into chunks. So there's various chunking strategy, like the more like a smart one is like agentic chunking. We in the future we'll talk about it. Basically, imagine basically the huge documents are split into chunks and stored in the vector database, and also the text is converted into embeddings like factors. That's the second step. Right? The third step is basically source data now is in the database. Okay, and once that is done, right? I mean, your database is ready. You have your data, right? So when the user number four is when the user query comes, right, with a like input question, and this question itself is also encoded into vector embeddings, right? Because you have to compare embedding with embedding, right? Compare number to number, right? So basically, your query is using the same mechanism to convert encoded into embeddings. Then we do similarity search in the database. We search relevant chunks and load it out. And then once the similar chunks is found, we'll use that to add it into your prompts. So that so basically here, when we issue a prompt to the LLM model, we augment the prompts, right? Basically, the documents here or chunks here being retrieved is used to augment the prompts. And then LLM is supposed to generate more better response, right? That's at least RAG is supposed to do. Especially when you have like a private, by doing this, right? The system ensure it use most relevant information from our stored data, right? Leading to a more accurate and up-to-date answer. Like if you have a new kind of data, you can just update your factor database, right? And you don't have to like change upgrade your whole model, right? Because that process can be very long and painful. So next we'll talk about LangChain. So by the way, I want to mention that both LangChain and the Llama index have added semantic chunking. I mentioned the chunking before, right? So there's different chunking strategy. Semantic chunking is also supported. Added to the library of LangChain and the Llama index. So what is LangChain exactly, right? LangChain basically is the framework that basically is like a Superman or like a mix of all the super useful things, right? Basically, the library you can use handy to build applications. Which is our topic, how to build applications using based on LLM. So the core components here, you can see that document loader, like importing the data, right? And vector store, we talked about this before, right? And the prompts and the chains for combine chain. We could talk about it later. Basically, it's chaining the component. So that let's say you have a linear like a sequential operation, right? and agents, which we'll have more on that later. So the framework helps the developer to create applications by connecting all these useful components together, and basically make your life easier. React is another useful framework. The name basically is a combination of the re and the act, both parts. Re stands for reasoning component. Basically, you can see basically you got an user query input, and it's giving some thinking and try to figure out like what to do with it, right? And the act, which is the acting component, basically is the specific real execution, right? This is still very abstract or fake to you probably, right? Doesn't make too much sense. So if you look at the LangChain agent, we often hear people talk about AI agent, or and the Salesforce has a product called Agent Force. The idea is essentially the same, right? The LangChain agent is the one actually doing the job, and it's based on React framework. Imagine this, right? When the user gets an query, let's say calculate something like a 354 multiply 89. It has a bunch of tools handy, right? In this case, in our diagram, it has some tool like a calculator, search, and maybe something more than that, right? Given users input, it actually starts thinking, right? Oh, I have these tools. Which tool should I use in order to complete the user's ask, right? So this is more like a think. Then let's say in this case, it knows it decided the tool should be calculator in order to fulfill user's request, right? So the real action is actually to choose that tool, right? It could be single tool, maybe could be multiple tool in complicated scenario, right? And then it actually invoke the tool with some tools input, right? And then come back with a result. And then the tool's result is translated into something user can understand, more like human language to tell user, right? So this process is like a think, act, observe cycle, and basically is what the LangChain agent does. If you go back to see this React framework, yeah, basically LangChain agent is a specific implementation, right? React is basically the framework supporting it, right? And just one more thing is about the land graph. This is a more complicated scenario, right? Because LangChain, speaking of the name chain, right? So it stands for like a linear chain. So it's pretty simple, like a one-way flow. It can only support like a sequential execution. You can take let's say you invoke one agent and or one tool, you got some results. Then the second step, you took the previous steps result, right? And further call agent or tool to further go process, right? Like one by one. So that's what LangChain is doing. Pretty standard linear execution, right? And the good thing benefits it can leverage result from previous LLM call, right? LLM result. And if you want to do things more complicated, you have multiple agents you need to coordinate, kind of like Airflow. You can have branching, a very parallel, multi-directional flow, which is more complicated, right? So this is land graph. Something good to know, right? LangChain is more like a Jenkins in our CI/CD pipeline, and Airflow is more complicated than that, which is like a land graph. So if we revisit the Apple Intelligence, right? Those apps are basically like those tools, right? So when user talk to Siri for some request or ask, the model, the LLM or the Siri, the behind it, the Apple Intelligence behind it is trying. It knows like those tools, which are the apps on your phone, right, or on your Mac, and then it give it some thinking, and it start choose some candidate app, right, and start talk to them by invoking them, right, which is the app intent, right, to trigger the app, and the app will return some result, and so this is basically what we just talked about the LangChain agent is doing, right? Very similar concept. So same thing like the planner here is basically like working as the thinking reasoning. Today we've talked about some basic concepts and like a RAG, FactDB, LangChain, LLM, right? Especially we have a basic understanding of the large language model and how to build an application with it. Next, we'll delve into more details, so component and specific usage, and play with it and have some real practice with it. Thanks.